It's math time with Heinz. It's math time with Heinz. Math time.
Hi everybody, welcome to lesson 5 here, where we're going to review everything you learned in 7th grade for months in a quick little video here. So we're going to talk about how to work with percents, how percents are somehow going to pop up and become exponential functions when we get to this later in the unit. So let's review. Rewrite each of these following percentages as a decimal. So what does percent means? It means out of 100, right? Out of 100, what is that? What is that ratio out of 100? So 5% really means 5 out of 100. So in my calculator, I'm going to do 5 divided by 100, and I get 0.05. 12 out of 100, 12% is 0.12. The trick is divide it by 100 in your calculator, or you can just move it twice. So 0.032. But again, I like just dividing it in my calculator to be 100% sure that I'm doing it right. So to go from a percent to a decimal, you divide by 100. You go twice to the left. Divide by 100. So let's get to a problem here. Gabe is buying a pair of jeans at a local store that are priced at $45. He knows the county he lives in, which we live in, has an 8.125% sales tax added onto the list price. If Gabe has a gift card for $50, can he buy the jeans, including the tax, right? When you go to the store and you scan something, you just don't pay whatever you think you're paying because there's that sales tax that goes to New York State and Orange County. They charge you extra sales tax for everything that you purchase. So does he have enough money is the question. So let's see. It's $45 and I'm paying 8.125% sales tax. So how much tax do I owe? Well, I owe $3.66 in tax. So 45 plus 366, that's only 48.66. He's good to go. Gabe is good. He can buy it because he only has to pay 48.66. So how do you do this quickly and in one step? So in one step, here's what we do. We do 45 plus the tax. So I'm going to write this. This expression here represents the tax. And notice these both have a 45 in them, so I'm going to undistribute that, and I'm left with 1 plus that decimal there. So when I'm at a store, here's what I do. I pull out my calculator and do this quick little multiplication. I do 45 times not just the decimal, I'm going to do 1.08125. And that right there spits out 48.66 like we got above. So the way that we do this is we do the initial amount, which I'm going to call P, times 1 plus the decimal. 1 plus the rate. It's the initial amount. We just don't multiply it by the rate. I do that 1. That 1 is representing the initial cost. That 1 represents the initial amount. And then I add on that decimal piece that I'm increasing it by. So let's do these in one step here. Let's increase 440 by 12%. So 440, I want to increase it. So 1.12. I'm going to turn it into a decimal and stick a 1 in front of it. 440 times 1.12 gives me 492.8. Increase 68 by 8%. Well, 8% is 0.08. So 1.08 because I want to increase it. So I'm going to do 1 plus the decimal. It's 73.44. And then I need to turn that into a decimal, so 0.035. So 120 times 1.035. This gives me 124.2. So again, to increase it, we never multiply by just the decimal. We do 1 point that decimal, 1 plus that decimal. That's how we can increase something quickly by a percentage. So when you're at the store and you want to buy something, this is the magic number, basically 1.08. 1.08 will get you pretty close to how much the total cost is going to be with tax. Megan buys a bag that costs $85, but the store is running a sale where the entire store is 40% off. So she's getting a discount here. Determine the price of Megan's bag before tax. So it's $85, and she's getting 40% off. So what's 40% of that? 85 times 0.40. She's getting $34 off. That's where she got 40% off. So what is she paying? Well, 85 minus 34 leaves me with 51. That's what she's paying. So how do we do this in a single multiplication? Well, it's the same idea. 85, and then I was subtracting away that discount, which leaves me with 85 undistributing here, 1 minus 0.40. So that's really 0.60. Let's think about this for a second. If I'm getting 40% off, that means I'm paying 60% of it, and that's my multiplier. It's not the decimal we multiply it by, it's 1 minus that decimal. So let's just do a quick thing here. If I was getting 30% off, what are you paying? Well, 1 minus 0.30 is you're paying 70%. If I was getting 5% off, what's your multiplier actually? Well, 1 minus 0.05, that means you're paying 95%. So you never just use that decimal to do it in a single multiplication step. You either do 1 plus or you do 1 minus the rate. You do 1 minus that decimal there. So decrease 620 by 10%. So if I want to lose 10%, there's two ways to do this. You can say, wait a minute, I'm going to do 1 minus 0.10. Or you could say, wait, if I'm losing 10%, that means I'm keeping 90%, which is 1 minus 0.10. So 620 times 0.90 is 558. Decrease this by 8%. So if I'm losing 8%, what am I actually keeping? Well, 92 and 8 make 100%. That's 1 minus 0.08. So 92% is my multiplier. That gives me 20.7. All right, I'm going to move that decimal twice because I can't do this one quickly in my head. I'm going to do 1 minus 0.035. I'm going to do 1 minus 0.035. What do we get? We get 122 times, what is that? 1 minus 0.035. We get 117.73. Okay, so notice when you're decreasing, you need to do 1 minus that decimal. You do 1 minus that decimal. So let's solve these problems here. Let's solve a couple problems and we'll call it a video. A student enrollment at a school is decreasing at a constant rate of 5%. So I'm losing 5% each year. What will the population be next year? So I'm losing 5%. So I'm starting with 2,300 people and I'm losing 5%. So this is a 1 minus 0.05. Which means I'm really keeping, there's a 0.95 there because that means I'm keeping 95% of it. That means I'm keeping 95% of it. So 2185. 2185 is what I'm keeping. Bacteria is growing. See, this is different. This one's growing. So this was a decay problem. This is a growth problem here at a rate of 20%. So when I'm growing, I take the initial amount, and then I don't use 0.20, I do 1 plus 0.20. So I just stick a 1 in front of that decimal there. Instead of doing 1 minus, I'm doing 1 plus. So 1 hour later, how much bacteria is there? Type it in my calculator here, and I get 384. All right, so notice this was a growth problem. So we did 1 plus the percentage. This is a decay problem. As I'm decreasing, I'm doing 1 minus the percentage. All right, let's finish with this one here. Number 7, the amount of money in a savings account increases by 1.5% each year. So when you have a savings account, the bank gives you this thing called interest, where they give you a little bit extra money back for letting them hold your money. The bank, when you give the bank your money, it just doesn't sit there in a little vault. They take your money and they invest it, and they make money off of using your money. So they take your money and they make more money by investing it places. So they give you a little thank you present in the form of interest. So initially, there's $250, and it's growing. It's increasing by 1.5%. So I'm going to do 1 plus 0.015. I move the decimal twice. I divide it by 100. So that's my multiplier. My multiplier here is 1.015. What do I get? I get 253.75. I get 253.75 there. Using your result above, how much money is there after 2 years? So this is 1 year. That's year 1. Another year goes by, so let's do another multiplication. Let's do another 1.015. So this point I get 257 point, money I round to 2 places. So I get 56. So again, I just type that into my calculator. This is year 1. This now is year 2. because I did another boost of interest to that account. How much money is in the account after 10 years? So it looks like I just need to keep multiplying. I'm going to take this answer and multiply by that, and then multiply by that. So this looks like I'm doing repeated multiplication. I have 10 years of interest to earn. I'm not writing out 10 of these. It's going to take too long. If I have 10 of those, put to the initial 250. So this is my initial 250, and then I kept multiplying each year by that multiplier to add on the interest. Well, I'm pretty sure repeated multiplication becomes an exponent because I have 10 of them. So that's what I'm going to type into my calculator. And this is how percentages become related to exponential functions. I would have 290.14 cents. So finally, let's write an equation for A of t. How much money do I have after t years? So instead of 10 years going by, I'm going to pretend like I have t of them. So we don't know how many of there are. There's t of them. So it's 250. Each year I multiply by 1.05, but t years went by. So this right here is an exponential function because the variable is in the exponent. The variable is in the exponent. And we're going to be doing this for kind of the rest of the unit going forward. Whenever I change or grow by a percentage each year, that's an exponential function. And our whole idea of percent increase and decrease, when we increase, we do 1 plus the percent. When we decrease, we do 1 minus the percent. We never just use the given percentage. And I'll see you in the next video.